Martin is the EVP and CTO and Director of Hewlett-Packard Labs. Martin has been responsible for leading HP's investment in the open source and Linux community for a number of years. Most recently, Martin was the Senior Vice President and General Manager of HP's critical systems and converged application systems. So at this time, I'd like to welcome Martin Fink to the stage.
Don't look down, but the internet is about to break the internet.
It's buckling under its own weight.
43,000 searches a second.
16 million tweets an hour.
$900 million in online transactions every minute.
And it's growing exponentially every day.
Doubling in size every 36 months.
That's not sustainable.
But what if we could build a new kind of server? For a new kind of enterprise.
For a new kind of world.
For a new kind of world. While using exponentially fewer resources to do it.
Most people call that a game changer. Some would call it a miracle.
We call it HP Moonshot.
Moonshot.
HP Moonshot will give the internet the room it needs to grow.
80% smaller than traditional servers.
Uses 89% less energy.
Costs 77% less to run. But it's bigger than that. Over the next 36 months.
It's 280 metric tons of CO2.
That will never be in the air.
It's 8 million square feet of forest.
That won't be cut down for industrial space.
It's 10 power plants.
That won't need to be built.
And it's the reason the internet just might have a future after all. So it can power our enterprises.
Our lives.
Our lives.
Our future. That's Moonshot.
And it's from HP.
It's time to build a better enterprise together.
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 Because it matters.
Because it matters.
HP Moonshot.
This is going to be big.
Good morning, everybody. That's kind of cool, isn't it? So, can you guys think of anything different I should be doing on my birthday today than be here with you? Gotta have a little fun, right? So, all right, so what we want to do is go through 3 different things. So the first thing I want to talk about is something that we call the new style of IT. I want to kind of bring you along the journey of how we look at how the world of IT has evolved and give you a sense for that. The second thing is talk about what we have today. And you saw a bit of that through the video. And give you some real data and some real pictures, and we actually have some real cartridges here, and talk more about Moonshot specifically. And then finally, the third thing is I want to take you a little bit beyond that. So how does Moonshot, the new style of IT, and the rest of our product portfolio evolve into the future? And so you'll get a sense for some of the things that we're laying tracks on, and we're getting, and hopefully connect the dots to a lot of what we're doing. So the other thing that I was sort of reflecting on, as Tom was saying, I spent 5 years of my life at HP actually responsible for our Linux and open source activities. I did take a hiatus going through and running our high-end server business, but the parallels here are really striking. Because if there's anything I learned through my time with the Linux and open source community is really the power of that, the power of the community, and just how much we can accomplish. And so that was all about the operating system, and that's where we spent most of our time when I did this through the 2000-2005 time frame. We focused a lot about the operating system and the beginnings of the LAMP stack, for example. And there wasn't too much discussion at the time around the power of the community as it relates to the other ecosystem, which is the hardware ecosystem. But you should really read of what we see here happening with ARM, what we're doing with Moonshot, as trying to replicate that. And so hopefully that theme will come out as I talk through the various parts of this. So let's start talking about this new style of IT and set some context. So this is, technology goes through waves, and we think this is just another exciting wave. And for those of us who've been around a long time, we've actually even lived through most of these waves. And when you actually live through one of these, you go through a first phase of, oh my God, what is happening to me? And then you start getting engaged, then you get excited, and it's just a really cool place. And then you look and behind you and you go, wow, that was a bucket load of fun to go through that transition. And so we see that we started the computing industry in the 60s, 70s, and 80s with largely a mainframe-dominated world. Then a lot of us moved through that first transition of client-server computing where we brought the power of computing closer to the individual. Obviously, no surprise to everyone, the internet changed the game. But the thing we have to think about when something like the internet comes in is we start doing a lot of the things we were doing before, but we do it in a new, cool, innovative way. And then we actually leverage the power of the technology to say, what can we do now that we couldn't do before? And so that's where the cloud computing came in, and how do we get to leverage the rest of the power of the internet and start building communities and social and a lot of what we hear now around big data. And so this has been an exciting transition. We're getting really big into the cloud part of this, and so we tried to come up with how do we wrap this around a nomenclature that we can use to sort of think through what is it that we're going through right now. As I said, we kind of had the mainframe era, we had the client-server era, we had the internet era, and so this cloud, social, big data, and mobile we're referring to as this new style of IT. And so those are the big parts that affect us as we think about the new style of IT, right? So we have the cloud, and the cloud allows us to change the fundamental business model of how we used to do everything on premise to how we can now leverage the IT infrastructure of the industry, or even how we continue to do it on premise but do it far more efficiently and do it a lot faster. If there's one thing that's actually been a universal constant through all of these generations and actually getting more and more front and center is the aspect of security. And I don't think that part's going to change, right? Security, privacy, data protection, all of those things are going to continue to be critical. And so that, if there's one constant through all of our technology transitions is the core importance and the foundation of security. Big data is big, right? Big data is all about how can we leverage the vast amounts of information that is being generated in order to change how we make business decisions. And quite frankly, and you'll see this later when I talk about some of the future stuff we're thinking about, I don't think any of us are fully, really internalizing and appreciating the onslaught of data that is going to come at us. And actually, the winners are going to be those who have the ability to take all of that data and turn that data into actionable information. And those who just absorb the data and just have data and just move data and just process data and don't turn that data into actionable information will be those who will be challenged. And obviously mobility, and in a broader sense the Internet of Things, is a lot of what generates that data, but it's not the only thing. And so we need to basically now deliver a new set of solutions that bring all of these capabilities together so that we can give you the infrastructure piece, the software to manage the infrastructure, the data, and the security, And then more and more and more, every conversation I have with so many customers is, I need help to get all of this done. And so a big part of the emphasis we have to have around here is the services to be able to deliver this new style of IT that's emerging. So let's just really think about, as I said, this onslaught of data and put it into numbers. But as I said, even though you're going to look at this slide, you're going to look at these numbers, I think most of you will actually agree with everything you're seeing here. I'm not necessarily convinced that all of us really understand and truly internalize what does it mean. What does it mean for my infrastructure? What does it mean to my data center? What does it mean to the business answers I now need to deliver? How do I manage this? How do I process this? How do I change the outcome as a consequence of this? So we have some impressive stats of what's happening today, whether it's what's happening in 60 seconds with tweets and games and any other amount of data that's being generated from app downloads and things like that, to the social network, to all of this grand expansion through the Internet of Things, of bringing more mobility data and having every device out there that we can think of, from air conditioners and thermostats to aircraft engines and so on, that will continue to generate huge amounts of information. And you can see some of the predictions we have by 2020 of the number of devices out there, the amount of data that's going to be out there, 40 trillion gigabytes. Not sure exactly what that is, but. And then the number of apps, and obviously our population that keeps growing, which continues to put the data. So what are we doing about this in managing this new style of IT, and how do we deal with this with people who have made significant investments in their existing infrastructure? So one thing we cannot lose sight of is the things that we are extraordinarily good at today, and all of the infrastructure that people still are using to run their traditional IT environments. And so we will continue, absolutely continue, to lead in the server space with our ProLiant family of servers, our SLs, and you'll see Moonshot. And we want to lead in every dimension of the server space. We want to be the absolute best in storage. Our 3-part storage is winning accolades everywhere. The industry is confused in the storage space, having to deal with multiple operating systems and multiple ways to deal with data. And when we saw that, we said we need to provide the best data infrastructure on planet Earth. We did that with 3PAR. We continue to do that. We provide the best data protection services. And these products are winning awards everywhere, and will absolutely continue to do that. On the networking front, we are leading the charge in places like software-defined networking. Also, network function virtualization, if you happen to live in the telco space. But we want to deliver the best networking infrastructure, whether it be the edge, the campus, the core data center switching, and we will continue to deliver that. And as I said, services to bring that together. So we have absolutely a strategy to be best in class in each one of these individual areas. But at the same time, we have many among you who are saying, hey, I can't think about this as independent entities anymore. The world is moving too fast. And the old world of having someone come to me and say, I want to generate a new business app, and I'd like to have it up in about 18 months. And then you have a project manager that goes in a room and talks to the server people and say, okay, do we have enough compute capacity? And then goes into another room and talks to the storage people and says, okay, do I have enough data storage to manage all this? Do I have the right interconnects to make sure I can transfer all this data? Does that work? And then get into yet another room talking to the networking team and say, all right, do I have the right switches? Do I have the right infrastructure? Can I transmit all this data? So on and so forth. Can I absorb all this? And then try to cobble this together. And wow, 18 months later, the new business application comes out. And I think that if that is your IT environment today, we want to help you get to push-button simplicity, where you can converge all that to one infrastructure and then have the ability to use concepts like the software-defined data center to be able to go from 18 months to literally minutes to provision new applications, where the software figures out from the infrastructure that's been made available, where you wire your data center once and deploy it in many different ways, to be able to think about that from one converged area. Recently we announced, and I would encourage you actually all to go look at this because this is pretty cool. If you go look at HP OneView, hp.com/go/OneView, to have a look at what it means to really be able to look at your data center from one console, from one management viewpoint, and be able to get to that push-button simplicity. And that's what Cloud System has been around, built around, is delivering that. And then we have the concept of the converged cloud, because the thing that happened with cloud as we went through the evolution is we have things like the public cloud, things that all of us may use, various consumer applications, and leveraging the public cloud out there. But enterprises were somewhat troubled by this, right? Do I want all of my data and all of my apps running on the public cloud? And in some instances it was okay. In other instances, people were troubled by this. And so we needed to provide the capabilities of what the cloud allows, which is this rapid provisioning of new application and new environments, but we needed to provide it in a private context. And so we also created the ability for you to do that on-premise and create a private cloud. Then we learned, hey, you know what? I got some of my environment where I really need to isolate this and keep this on my premises. But I got other parts of my business, it's probably okay for me to leverage the cost and simplicity of what's available out there. And so then you get to things like virtual private clouds or hybrid clouds and what we call cloud bursting, where when you run out of capacity, you can start leveraging the public cloud. And then we had yet another model, which is, you know what, HP, can you just manage all this for me? I kind of want all this cloud goodness. I do like this push-button provisioning of new business applications, but I don't really want to manage that infrastructure. I really don't want to look after that, so would you look after that for me? So we did that too. And so those various cloud paradigms, we kind of combined and said that is our converged cloud offering. And that allows any one of our customers, any of you, to say, this is the model that's right for me, but at the same time be able to move back and forth between the various models in a very consistent way with a common infrastructure. And so we've made huge investments into the OpenStack infrastructure. We're big proponents of OpenStack. We do a significant number of contributions to that world. We've based our public cloud offering. That's how we deliver our enterprise and private and hybrid cloud capabilities. If we manage your cloud for you, that's what it's going to be based on. And again, we leverage the power of the community where we deliver a lot of our expertise in the enterprise space for OpenStack while also working with all of you to continue to enhance the OpenStack ecosystem. And we're taking that leadership position there to continue to foster this ecosystem and the community. So I've now given you a flavor for what we call the new style of IT, how we still want to support the traditional environments, be best in class in each category, but also be able to bring these things together in an easy and simple way. But it's our job as HP to also look at what are the consequences of what we're doing. And we just really look at this and say, let's start doing some math and let's start drawing some charts around what happens as you continue to grow the amount of data that's coming at you, right? We saw that with the 2020 and beyond, right? What happens when you need the amount of compute power that you need in order to be able to deliver that. What happens to things like footprint, size of data centers, the amount of cooling, the amount of energy? You know, it's kind of fascinating to me when I've had a couple of interesting customer conversations. One says, we now have to start looking at whether we position our data centers near the Arctic Circle to take advantage of Earth's cooling. Right? Just to give you a sense of the problem some folks are running into with their data centers. The other one, I was sitting in a room, it was an internal HP meeting, and we were talking about this, and I had some of our sales teams in the audience, and we were talking about a variety of topics, and a sales rep stood up, raised his hand, and he said, you know, everything you're talking about, Martin, is really cool, and I actually have a customer who wants to buy everything that you're talking about. Blank check, wants to buy it. I mean, who doesn't want that, right? But he says they cannot get more power from the city. So I want to buy your stuff, but I got nowhere to put it, and I can't get more power from the city. These are the kinds of problems that in some ways might feel like they're way out there and they're in the future, but they are starting to happen to us today. And we have other charts that we use to show that the cloud today uses more power than entire countries do today. And so today's IT is all about the virtualized data center and in order to provide a predictable environment. But now what happens is we need that next generation of the data center that gives us the performance we need where we need it, that can handle the billions of devices that are coming at us and the amount of data that's being generated. And that's where the future of IT is going. And so in order to change the game on this, we created HP Moonshot. This had never been done before. It was revolutionary, and it was really about how do we leverage the Arm ecosystem, the low power ecosystem, in order to create a radically different kind of compute capability. In Moonshot, and I hope you guys will take the time to go through and see some of this stuff. I'll show you some cartridges here in a minute. But the interesting thing with Moonshot is it really is a bold, completely new and different kind of infrastructure. We have a complete set of fabrics, right? We have a networking fabric, storage fabrics, management fabrics, in order to allow you to combine and define your compute capacity on the fly, on demand. We combine these cartridges with the capabilities of HP networking. So truly in one infrastructure, you have an impressive set of capabilities. So this is no compromise from a compute infrastructure capability perspective. But we do it in, as you saw from our TV commercial, and as you see here, 80% less space, 77% less cost, 89% less energy, and significantly less complexity. So truly, truly changing the game. And so hopefully the theme that you're also getting here is that we are not trying to do this alone. We need all of you to come along for the ride. And so in order to do that, we have actually created a set of programs to allow you to come along with us for the ride and for the innovation that we're going to be delivering with Moonshot around it. So the Pathfinder innovation ecosystem allows us to include not just open source software partners and this software ecosystem as I did in the previous life, but also now recreate that kind of an ecosystem with hardware partners. And we provide you with our centers, our discovery centers that allow you, our discovery labs that allow you to test out your innovations, see how this stuff works. And we work closely with you as part of the development process, and we want you to shock us. We want you to create the cartridge of all cartridges. We want you to floor us. We want you to change the world and create the next set of cartridges that nobody has thought of, but that the ecosystem provides you the platform to focus on your innovation, what you do best, and what you can deliver to the industry. And we want to enable you to be able to do that. And that ecosystem is very, very critical to us. Now, we've been doing this for a while, and we have early customers that are really working with us to start creating that innovative set of applications. And you can see CGG is working on geoscience and using this in order to do a different kind of energy exploration all over planet Earth, be able to model the planet to be able to find new sources of energy. And so it's a great example of how we use this. You can see we have customers in the cloud ecosystem that also see the power of Moonshot, right? And leveraging its capabilities to radically change the profile of their data centers and bring you the capabilities. And then, of course, and this one's kind of special to me because, you know, I also run HP's research labs. And when you run the advanced research labs, one of the communities you try to stay close to is the university community. And, you know, we have a lot of PhDs and postdocs and students that work with us. And having that relationship with the universities is always pretty special. It's pretty exciting, and it's where you see a lot of the incredible ideas that come out. And so working with universities, in this case in the Purdue University, to do research is actually pretty special. So with this, you can see that we've got an impressive set of capabilities. And so just to give you an idea of another customer that we have using this, there's one very special customer, and that customer is actually HP. And so, you know, people say, hey, you got to tell the story about how we eat our own dog food. I like to think about it how we eat our own caviar. So can we move the video, please?
HPIT is one of the most diverse and complex environments on the planet. More than 300,000 employees use our information systems. The team is always looking for new technology that gives us a competitive edge. When I first saw Moonshot, I was blown away. It was immediately clear what the potential is for this product to make a major difference in our IT environment. We chose the gateway to HP's web presence, hp.com, to start our deployment of Moonshot. Our migration was fast and simple. Within an hour of go live, we were taking 10 to 12 million hits per day from our old existing Unix servers to only 6 Moonshot server cartridges. The results have been amazing. The existing HP UX boxes process the traffic using up to 3.3 kilowatts each, and we can stack a maximum of 2 of those in a rack. With Moonshot, at up to 19 watts of power per cartridge, we are using dramatically less power for the same job. We expect to run Moonshot on the equivalent power of 12 60-watt light bulbs. The lower energy bill isn't the most exciting part for us. It's what we can do with the power and cooling infrastructure inside each square foot of our data center. This is truly revolutionary. As a CIO, it is the answer I've been looking for, and that's powerful.
All right, so as the guy who used to run the Unix business, I did have some issues with this video. But it is a great example of eating your own caviar. And so when you guys go and you navigate to hp.com, you are using HP Moonshot. And it is a great example of the power of what we can do. And we are, in all seriousness, doing this more and more, where we come out with innovations. We want to make sure that those innovations are relevant to you, that they will work for you. And the interesting thing about having them deployed in HP's IT environment is that you're usually dealing with the biggest, baddest, most complex environment on a global scale from an IT perspective that almost anyone can dream of. And so we tend to be pretty confident when we know we can make a difference, as Ramon was saying, our CIO, of what we can do. We tend to be pretty confident we can bring based cartridges, and these are available in our Discovery Labs now. They'll be shipping next year with new processor technology. So the thing, you know, when you use slides like this, you can see we have our 32-bit Calzada cartridge, we have our Texas Instruments and DSP-based cartridge, and now our first 64-bit Arm cartridge, is that sometimes it's better if you can visualize them. So the team kind of gave me this. Team did say I only have 2 hands, but I do have these cartridges here. If we can get the camera maybe so you can kind of get a real sense for, and if you can go through, I think we have some of these also available for you to go through. This is, if you compare it to the picture, this is our first 64-bit Arm cartridge. As you know, as I said, this is available in the Discovery Lab, so you can build your software solutions, test your software solutions and your software innovations. This is our Calzada-based cartridge here. You can see this is actually 4 servers, right? So think about this, right? So for those of you who run, you know, Proliant DL380s, you know, 2-socket, 2U server, and now think of this as 4 servers, and you can see the memory on the back of the cartridge here, just checking the video. So 4 servers and memory on those servers is actually pretty exciting. And then the other one that I kind of like, and from a, you know, encouraging you to innovate and think about new things, is this Texas Instruments, where we combine ARM with digital signal processing for specialized applications. And the more that we can encourage you to think about, how do I combine the power of ARM, the power of specialized ASICs or other applications for video processing, audio processing, etc., to then combine that again with innovative software that leverages the open source ecosystem to create a new set of applications, right? I want us to do stuff now that we have never done before. And that to me is what's so exciting about Moonshot, is where we can do that with this new capability. So it's actually pretty exciting to see how we do this. So I want to spend a minute here talking about how we think about this holistically, right? Because it's sometimes you can talk about the chip, you can talk about the ASIC, you can talk about this piece of software, that piece of software. And I think it's important for everyone to understand that it really is a complete ecosystem and a complete, you know, wheel of innovation that all comes together. So obviously, we want to make sure that this is relevant to you, who are all our customers out there. And then we want to look at, what are the workloads? What are the applications that people want to run, at least that are available today? And so we want to make sure that the cartridges that we work with you to innovate on allow us to really leverage the workloads that matter the most to you. And so you'll see, as we start thinking about things like big data, you know, how do we combine and expand environments like Hadoop with our cartridges in order to be able to create this new kind of applications. Obviously, the tool set's expanding, and we continue. We'll probably, you'll see coming from us shortly here, a set of expanded tools and capabilities that will allow you to create open source environments and open source applications to leverage this ecosystem. Linux, obviously very close to my heart, but also a key part of the ecosystem. And we work with all of the distribution providers to make sure that we are tuned and optimized, have the drivers, because as I said, Moonshot is a platform, right? And that platform, as I mentioned, has a combined set of 4 fabrics. One of those is a management fabric. We want to make sure we have all of the drivers and everything working for that fabric, for the storage fabric, for the networking fabrics, etc. And so we need to make sure we enable all that for you. Obviously, we have the silicon, not just the ARM silicon. And for those of you here who are hardware designers and ASIC designers, you know, I want all of you to be our new best friends, right? create that next cartridge, blow our socks off and combine that with that software ecosystem. But then, as I mentioned, we provide the Discovery Lab, and part of the reason we provide you the Discovery Lab is so that you can actually see what happens when you take either an existing cartridge or one that you're creating and combine that with the rest of the ecosystem around you and see how your workload or your application or your environment performs. And then the virtuous cycle repeats itself, but in a very open, community-centric way. Like I said, I really love this, combining this open source Linux ecosystem with a silicon-based ecosystem in a very open way. It's in our DNA. We've been doing this for well more than a decade, and we know how to leverage this and do this well. Okay, so now let's transition to where we're going and give you some idea of how this connects the dots into a future, right? So we saw how we came from the past. We're now delivering the new style of IT. We've talked about our Moonshot and our product lines that are available today to enable you to leverage the new style of IT, and where do we go? So let me start with memory and storage. So today, I'm told I have all the geeks in the room, so we're going to go into geek land, okay? So today, if you really think about the compute architecture and you think about memory and storage, we are always dealing with memory as a constrained entity. And so because memory is always a constrained entity, what do we have to do? We have to use it as temporary space, and we shuttle things off to storage. So what if we actually lived in a world where we're able to combine the capabilities of memory and storage into a single entity, leveraging all of our 3-PAR data protection and data management capabilities? We get to a massive, universal, properly managed memory pool that removes all of the hierarchies of data shuttling back and forth and look at it more as a single entity. And I'll let you, after this, reflect on, geez, what does that really mean for the rest of the software stack? On the compute side, we really have come from, let's call it 20 years of general purpose compute, right? We use general purpose processors, and we ended up with general purpose compute, and it's very good. And there are still places where we want to do that, right? Where we want to deploy everything we have today, and we want to take advantage of those general purpose capabilities. But increasingly, as we look at the combination of universal memory and that next class of applications that we want to run, what we actually see is a move to energy and algorithm optimized ecosystems. That's a mouthful. But increasingly, I think we will start to see the data we want to process and the processors specialized to the kinds of activities we want to do. Do I want to deploy a general purpose processor in order to do video processing and video analytics? Maybe I want to create a specialized SoC that is only really, really good at doing that. And so, connect the dots of how we want to bring together massive pools of universal memory and specialized processing, and you can start thinking through the applications that we think about that we can start to create. Today's data center is built on electrical copper interconnects. By the way, if this is that picture, if that's what your data center looks like, you have other issues that you should go deal with right now. But the reality is the data centers are really built on this. And so in order to be able to think through the big data paradigm and start thinking about the exabyte scale and beyond, and if you think about where all of the energy is consumed in machines today, you start to think about we need a different paradigm for interconnects in the system and beyond. And so the idea of integrated photonics and thinking through how photonics has been used for long-distance communications today into how does it become the core fabric for system interconnects and bring those together. Now the next one we've talked about, which is the open source data management platform. We come from a world where it's all been about transactional data, very important. And I actually don't think that world is going to go away anytime soon. There is still very much a need for transactional data, ACID compliance, and all of those things, right? And we still need to do that. But the reality is that in terms of data volumes, the transactional data today is already getting dwarfed by things like click streams and event processing and security events and log files, and the list goes on and on. And so while we will never stop doing our financial transactions, actually I'll tell you a little funny story. I have some people who come to me and say, hey, big data is, petabytes of data, and, transactional data is, my biggest transactional database is a few megabytes, and so therefore, my big data is way more important. And so then I usually ask them, okay, so if you have to choose about losing the video of your dog on a skateboard doing a fancy trick and your bank balance, which would you like to lose? Right? So transactional data is still going to be very important, and let's not get confused that there is a relevance to the data, there is a time value of data, and then there is a size value of data. But we are going to see us move more and more to managing the next generation of data that supplements our transactional ecosystems to be very open source centric. And we're seeing this today, right? I'm pretty sure there's nobody in this room who hasn't heard of Hadoop, and then all of the ecosystem building even around Hadoop with HBase, Pig, Hive, so on and so forth. And so we're already seeing the data management platform of the future really having a lot of the open source ecosystem built around it. And so finally, the other thing that we see evolving is around how do we access and visualize the data. So today I wouldn't be shocked if the vast majority of the people in the room have a phone, a tablet, and a notebook, and they probably have a desktop at the office, right? So we have this multiplicity of devices. I think some probably have some smartwatches or the Pebble watch on top of that, and the list goes on. And so we are really trying to think through a world that is today very device-centric to a world where it's about the content as opposed to the device. And the magical world for me is when I can pick up any device. If I walk up to you and I grab your tablet, where that tablet instantly becomes mine, right? So in other words, all of my personality has immediately shifted to whatever device I pick up. Now you might have some issues with me taking your tablet that way, but we'll deal with that when we get to it. So this is kind of how we think through. So let's talk about a little bit more detail about some of these. So the thing that's interesting is if you think about computers today, the fundamental architecture of computing really hasn't changed in 60 years. Right? So just take a step way back, right? We're part of an IT industry. We believe we're one of the fastest moving, most innovative industries, and we are. But if you just take a step back, computers since the dawn of time have been built with CPU, memory, I/O. Initially that I/O was all storage, or mostly storage, and then eventually networking came along. And that really hasn't changed. And in fact, if you think through the whole virtualization movement, all we did was actually completely replicate that architecture in software and virtualized it. And we think we are on a path where there's an opportunity for the first time to fundamentally change the base architecture of computing, where we collapse some of the hierarchy and have specialized processing photonically connected to large pools of non-volatile memory and really change the paradigm of how we do compute. And for those of you who are system software and operating system developers and things like that, I'm sure as you think through that, you'll think about a lot of the implications that occur to the software stack and everything else. So think about this in terms of how this changes how applications are built, right? So, you know, open source, the traditional enterprise ecosystem was built around predefined schemas. You need to know what your data looks like ahead of time. You build your schema, you deploy that, you have a very clear understanding of where all your data is going to go, how it will be partitioned across your ecosystem, how your users are going to view that data, all very defined ahead of time. And we think that what happens now is, and it's already starting to happen, right? So this is, the world is going to continue to move like this, is where you now have the ability to just dump your data into a lake and figure it out later. But you want to figure it out as quickly and efficiently as you can and scale out and have very task-specific SOCs. And so we see this tremendous opportunity to build a radically different kind of application, where we combine, as I said, the OLTP or the transactional data. It doesn't go away. But how we combine that data, which gave our CIOs, our CEOs, or our C-suite community the business answers it needed to make decisions of yesterday. But now think of an application where, let's say, Meg, our CEO, comes into work, and she gets all of that financial data to run HP as a company, and that financial data might tell her, go do these things, right? Go change pricing on some products, or go add more sales to this, or add more technical capabilities, go grow this business more, change pricing paradigms, and so on and so forth. Would have been the classic business decisions. But now we live, for example, in a world of clickstreams and tweets and Facebook and everything else. How do you combine that with all of that big data, right? That social data, all of those clickstreams and everything else, to now radically change the answer? And where you might have previously used your raw financial data to say, I'm going to make a price change, up or down, doesn't matter. But now all of a sudden your social media trends tell you, if you do this move based on your transactional data, you will actually make things worse. And that is a new kind of application and a new kind of business decisions that our business leaders of the future are going to be required to be able to support. And finally, I talked about the device versus the content. And today the reality is that we are very device-centric. As I said, we have phones. Some of us have multiples. We have tablets. We have smartwatches. We have laptops, etc. And we do use the cloud and we try to sync stuff across, but it is, for the most part, still relatively awkward for us to do all of that. And so our focus as we do our research, right? Remember, part of my job is our advanced research lab, so I'm giving you a hint as to the kind of the stuff we think about, is how do we think about the content associated with an individual and how that content is available no matter where you are, when you are, and how you want to consume it. And it's not an easy problem to solve, because there's another part of this, and that's kind of what the picture on the right is trying to tell you, is that trying to visualize big data is actually proving for us to be a very interesting and fascinating research project. Because we have everything. If I brought you to our building, we have, in our basements, we have huge walls covered with monitors. And we can take you in front of these big walls And we can take all of your data and we can plaster it along all these screens. And then we kind of analyze what's the human reaction to that. How does our brain process that? And it's very fascinating for us to see that while we're able to plaster a lot of data on a big wall, making sense of all the data that's on that wall is actually incredibly difficult. Coming to the business conclusion is very, very difficult. And there's absolutely a piece of this which we want to automate, right? So how do we create the software tools that will pop out for you what is the most relevant information that is on that wall of data? And we'll continue to do that. But the other part, there is always going to need to be the human who looks at the data and spots something to go analyze deeper. And so, for example, we're doing significant experiments in 3D visualization. What happens when you replace that wall of 2D charts, Excel or PowerPoint charts and bar charts and line charts, etc., and replace them with interactive 3D elements? And it's actually fascinating to see as we analyze the human brain's reaction to that. I'll give you part of the answer. One of the things that we've discovered is when it comes to looking at data in 3D, first of all, we can spot relevant information far more easily and far more rapidly. Part of the challenge is a couple of things. One is the average person manipulating 3D is actually quite difficult, right? Actually, part of the fun I have is I go in our labs and we have like a 3D mouse and a joystick, and I actually fly through data. That's kind of cool, actually. But can all of you who work for companies imagine your CEO coming into work one day, sitting in a gaming chair with a 3D mouse and a joystick and flying through the business data, right? It's kind of cool, but probably not likely to happen, right? And so what we're trying to figure out is how do we basically make that visualization of data easier to see in 3D so that we can spot the trends. But then the next part that's also relevant is size matters. So right now we need that big screen for you to be able to internalize and view this data. And so our other goal is how do we take this to your content onto a device that you can hold and still spot all of those trends. And so we think this combination of universal memory, specialized processors, looking at data for different answers, and then visualizing that data differently is going to be pretty powerful. And so the question then goes back to you. How will you utilize all of the capabilities we've talked about today in order to change the answer for your company? We've walked you through the past, we've walked you through what we're doing today, we've given you a glimpse into the future, and now the ability is for you to leverage our Moonshot ecosystem, hardware and software, from the silicon to the app, in order to change the answer for your business, your company, and for the ecosystem and the industry overall. And I sincerely hope, tell you that, make it my birthday present, create the next world-class Moonshot cartridge. Thank you very much, everybody.
Thank you for joining us for today's keynotes. For those of you joining us for our technical program, the sessions will begin at 10:30 in ballrooms A through F. And please be sure to join us tomorrow at 9 a.m. for Arm CEO Simon Seegers.